Statewide growth has road construction around Texas going at a brisk pace. One of the ways being used to help speed up the process is the use of longer and taller bridges.
Prestressed concrete girders are one of the most commonly used girder systems in Texas for bridges. Historically, though, they've been limited mainly for girder systems that are less than 150-foot span. But over the last 10 years, there's been what we call spliced concrete girders that have been utilized. And that's kind of been the difference between steel girder systems and concrete girder systems, is that steel is very easily spliced together. So you can end up having very long bridges built in many pieces and spliced them together. And now you can start doing that with concrete girder systems as well.
Working with the Center for Transportation Research, the Texas Department of Transportation studied how stable long-span girders interacted in various stages of construction.
So we noticed there was a lot of research done in that realm of how do we keep things stable during construction, which is the bridge's most vulnerable time. And we decided we needed to fill in that gap instead of just guessing at what concrete was going to do as these shapes changed historically from what we've been building in the past, that we needed to do research and see how those were actually performing out in the real world.
Laboratory testing with full-size girders were used to study their stability and how loads would be distributed.
And we looked at cases where the girders were fully elastic and then also where they were heavily cracked and so on, just again to kind of see how the material properties and section properties would change. Then once we were able to do that, we were able to validate finite element models of these girder systems so we could then go into the wide range of geometries that are used in Texas bridges and really kind of assess the stability behavior for these girder systems during construction.
This led to developing comprehensive guidelines highlighting what should be done to make sure girders are safe during construction.
We looked into some buckling equations that we currently use for steel, and those are working with the models that we ran through on this research. The engineers can use what's in the code. We didn't find any sort of bust or concern, which is part of the reason we do this research. TxDOT specifies that we need to use the diaphragms at the supports on these bridges, but we're also going to go ahead and recommend using those concrete diaphragms at the midspan. It really helps distribute the moment, and we're going to get better bridges out of putting that in place.
TxDOT continues to advance research to make bridges larger, with less delays for the traveling public and just as safe as bridges in the past.
When we talk about stability, I think a lot of the traveling public and so on and non-engineers can understand buckling like as a kid where you had a yardstick or a beater stick, you push on it and it would buckle, right? We learned stability at a very young age. That's what we're talking about with stability, is that buckling behavior. And what we've really been able to do is go through and solve and make sure that we have solutions that won't happen, because we don't want that to happen in our structures, right? So anyway, I think what we've done here is as we're pushing the limits of prestressed concrete applications, we can end up now making sure that we understand them and we don't have things like that buckling happen.
One of the things that's cool about spliced girders and prestressed concrete is that we're getting better every day at making them longer and taller so that we can make bigger bridges.
For more information and to find the publication for this project, please visit the TxDOT Research Library at the link shown below.